right, zero product property. What we did for bell work is we solved when we had an equation that equaled 0. Today we're going to have some binomials that equal 0, and our job is to find out what x truly is. Because once we factor, we can still go further if it says equals 0. Equals 0 is something that we'll see when we do, well, it won't say equals 0, it'll say like equals y. But that's something we do when we start to graph quadratics. And right now we're just factoring quadratics. So factor, what we've been doing for the past week. I want your own words of factoring. I want a definition of factoring. Definition, factor. What have we been doing? We have a trinomial and what's the words to describe what we're doing?
Breaking down.
Okay. We're simplifying. We're making it into smaller numbers. So our answers are usually 2 binomials, right? 2 parentheses. Okay. So you're right. That's what we've been doing. Okay. So now what's happening is I actually have to solve for x. So what you need to do is you need to split up the parentheses into 2 equations. So basically what's happening is this x minus 7 needs to equal 0, and the x minus 2 has to equal 0. Both of them need to be solved separately. So I'm going to write it twice. X minus 7 equals 0. I don't even need the parentheses because literally, if I put the parentheses around them, all you would do in the next step is take them off. So you don't need to write the parentheses there. And I'm also needing to do x minus 2 equals 0. What this is doing, it's called finding the x's, finding the roots, finding the solutions. And it's also finding the x-intercepts of a graph. But we will get to that when we start graphing. But we need to know when you factor and when you break down a trinomial, what 2 numbers could I plug in for x to get 0? So solve the blue one. How would I solve the blue? Add 7. Okay. How would I solve the red? Add 2. Okay, so what does this mean exactly? I have these 2 answers, a positive 7 and a positive 2, but what does that mean? It means that if I plugged my x's back in, okay, I am going to plug my x's back in right now. I'm going to write it in black. I don't want you to write down what I'm writing in black. I just want you to stare at the board while I'm writing in black. Because black is my check. It's me checking to see that I'm doing the right thing. So here I go. If x is 7, then I'm going to put, instead of x up here, I'm going to put a 7. 7 minus 7, parentheses. What's my other x that I got? 2 minus 2 equals 0. Can you please check the math that's there? 7 minus 7 is what? 0. Times, what's 2 minus 2?
0.
Does that equal 0?
Yes.
So what we're doing is we're finding the zeros, we're finding the answers to x, we're finding the solutions, we're finding the roots, we're finding the x-intercepts. There's so many words that mean the same thing, but we'll talk more about it when we graph. Right now, I just want to know what are my 2 x's of my trinomial. After I factor, what 2 numbers can I plug in for x? So the point of this lesson is to solve for your variable, So separate your two parentheses. One of them is going to say m minus 3 equals 0. One of them is going to say m plus 9 equals 0. And really and truly, the answer is just the opposite of the number that's there. Like, you see how there's a negative 3? My answer is going to be positive 3. See how there's a positive 9? My answer is going to be negative 9. So I'm assuming that some of you could actually just do this in your head. You can just look at the parentheses and say, something take away 3 has to be 0. What? Take away 3 has to be 0. 3 minus 3 is 0. Easy. Okay, so now with number 3, I don't have two binomials. I have an x and I have an x minus 5. They both need to be set equal to 0. X equals 0 and x minus 5 equals 0. Because many times on a parabola, you're going to have two x-intercepts. A parabola is, if we graphed these trinomials, we would get a parabola, a U-shaped graph. So my two answers are, oh look, the first one's already done for me. Woohoo! I'm done. What's minus 5 equals 0? Those are my two x's. Those are my two solutions. Those are my two roots. Those are my two x-intercepts. All these words. Okay, now do number 4. Separate them. First one, 5x equals 0, and second one, x plus 8 equals 0. Well, the work means that I'm going to have to divide by 5, but your answer is still going to be 0. And then minus 8, x equals negative 8. So this is also pretty easy. Any questions so far? Okay. So what do you suppose I'm going to have to do? Because at the end of all this, this is what I want. X equals what and x equals what? What are the two numbers that I can plug into x and get a 0 out? So what am I going to do? What would be your guess on how I'm going to do this?
X squared equals 0.
No, tell me the in words what I'm going to do.
Oh, so you're going to take out x squared and then leave negative 7x plus 10. Or combine like terms.
No, I don't want to do that. Can I get a different thought? On number 4, or wait, let's look. Okay, everybody look at number 2. The only way that I could solve for equals 0 is when I had two parentheses. On number 3, I had an x and then a parentheses, and on number 4, I had a 5x and then a parentheses. So I can't solve for 0 yet until I actually get my parentheses, or my numbers that can be solved for 0. So what should I do with my x squared minus 7x plus 10? I'm pretty confident that exact equation was written on the board yesterday when we were reviewing. It was the last problem on the board right here. Right there. What did we do? So what's that called? Factoring. You have to factor it. You have to get this before you can even begin to solve for x. Okay, how do I? You said 1 and 1. Okay, what makes 10?
2 and 5.
I need to make a negative 7. 1 times 2. 1 times 5. How am I going to get a negative 7 out of that? If they're both negative. But what's going to be inside my parentheses then? Like this 2 has to be negative, and this 5 has to be negative. X minus 2, x minus 5. Yes, I had to factor first. Now I can set it equal to 0. Okay, do it. Solve them both. Or do it in your head if you are... Ah! What are my 2 roots? What are my 2 zeros? What are my 2 x-intercepts? 2 and 5. That means that if I plugged back in a 2 into the trinomial, or if I plugged back in a 5 into the trinomial, they would both equal 0 when I did the math. Either one would make a 0 answer. 2 squared minus 7 times 2 plus 10, that would equal 0. Or 5 squared minus 7 times 5 plus 10, that would equal 0. Ooh, number 6, it doesn't say equal 0. Huh. I need to do something first. It doesn't say equal 0. What's that? Add 30. She's right. Let's make the trinomial look good in factored form. Okay, now let's factor it and come out with 2 binomials. Is it going to be, oh my goodness, so many things. 15 times 2, does that make 11? 30 and 1, does that make 11? 6 and 5, does that make 11?
Yes.
6 and 5, you're right. Oh, I shouldn't have put that line there. But I want positive 11, so x plus 6, x plus 5 equals 0. Now find your x's. What are my 2 x's? X equals what?
Negative 6.
Negative 6, and x equals what?
Negative 5.
It's just the opposite sign. Okay, I am moving on. 7 just looks weird because I started with the 0, but it's still fine. Here's going to be my challenge. 2 numbers that are going to multiply to make 144 but add up to 15. Well, the obvious one that you've known since elementary school is 12 times 12. Does 12 times 12 make 144? Okay, does 12 times 12, or does 12 plus 12 make 15?
No.
So then we have to sit and we have to just work it out. Try things on the side. Well, if 12 goes into 144, 6 must. 6 times 24. 8. Does 6 and 24 make 15? Okay. 8. Oh, 8 goes into it. 8 times, okay, it goes into 144. 164. 88. 8 times. 18? Do 8 and 18 make 15? Okay. 2 is obviously too crazy. 2 times 72? No. I don't know. I'm not going to give up. Come on, man. I don't give up. Hey, if 72 and 18 go into it, then 36 goes into it. Because 18 times 2 is 36, and 72 cut in half is 36. 36 times what? Oh. Well, that's no good. 10, 11, 12, 7? No. 5, no. See, here's the problem. This one was super close, this 6 times 24. And since 7 doesn't go into it and 5 doesn't go into it, then that's how I can come to the conclusion that it is non-factorable. But I had to try every option first. I'm not going to give up just on the second try. So we can't solve it using factoring. I'm going to teach you in a couple chapters another way to solve it though. That doesn't involve factoring. It's like a special method to solve for x. Oh, number 8. What do I do first? Because I want equals 0, remember?
1.
Yes. Okay, so here we go. What makes 2? What makes 1? I need to make a 3 somehow out of this. 2 times 1 is 2. 1 times 1 is 1. They also need to multiply to make a positive 1 at the end. Wait, both of them negative? Okay, then that means that my 2 times 1, this is going to have to be a negative 1. My 1 times 1, this is also going to have to be a negative 1. X minus 1 and 2x minus 1 equals 0. Check your last one, you guys. Does negative 1 times negative 1 equal positive 1? Okay, that's a good check to do, like, pretty much a lot, often. Okay. Set them both equal to 0. Find your x's. Wait, 2... X equals what? 1, and then X equals what? This means that if you plug in 1 into your trinomial, it will equal 0. If you plug in 1/2, it will also equal 0. Those are the two solutions. But that one was just a little bit trickier, because my answers was 1/2. Okay, number 9. What makes 2? What makes 3? But I need a negative 1 in the middle. See this negative 1 right here? So, 2 times 1 is 2. 1 times 3 is 3. 2 and 3. Negative, I need this to be a negative 1. A 2 and a 3 need to make a negative 1. Negative 3. That means that my 1 times negative 3. That's how I got my negative 3. 1 times negative 3. The 2, that can be positive, right? Let's check. X positive 1 right here. And then 2x minus 3. Equals 0. Solve for your x's. Set them both equal to 0. X plus 1 equals 0. 2x minus 3 equals 0. And you just solve for x. Divide by 2. Ooh, fraction. What's 3/2 written as a mixed number?
1 and 1.
1 and 1/2. So here's what we would do. If you plugged in negative 1 into your x's, you would get equal 0. If you plugged in 3/2 into your x's, you would get equal 0. X's are your solutions, and this will all connect together when we start graphing, and you see that those are also the x-intercepts. All right, last one. Try it on your own. What'd you get? No one got it? 2x minus 5. And what else? 3x plus 1. Let's see. So that equals negative 5. Negative 15 plus 2 is negative 13. Awesome. That's the answer. Set them both equal to 0, you're going to get fractions. So solve for 0, get your fraction answers. There's going to be 2 fractions that you can plug in for x, and you will get 0. All right, those are your 2 x's, your 2 solutions. Yes, Jason?
Would you have a different answer?
Did you get a different factored answer? What'd you get?
2x minus 1, 3x minus 5.
And 3x what?
Minus 5.
6x squared. Negative 15x. Negative 3x. Positive 5. Ooh, problem. This is going to become negative 18x. Positive 5. So you know what? That would not work.
What about 2x plus 1 and then 3x minus 5?
3x minus 5?
Yeah.
Let's try it. 6x squared. Negative 10x. Positive 3x. Negative 5. 6x squared. Negative 7x. Oh man, nope. Can't do that one either. Good try though. Because it's always worth checking to see. Okay, so what I have for you, let's start on classwork.